Hi everyone, welcome back to the videos. In this short series we're going to be looking at special types of functions called one-to-one functions, and we're also going to look back on what it means for something to have an implied domain. Okay, so that's what this series of videos is going to focus on. So first of all, one-to-one functions. Okay, so in the last series we looked at what functions are, what makes something a function rather than just a relation of some kind. Now that we know what a function is and how we can test for whether or not something is a function, there's a very specific class of functions which are called one-to-one functions. Okay, so let's have a look at the definition. A one-to-one function is a function where for every y value there is only one corresponding x value. Okay, so it's sort of like the reverse property of testing for whether or not a relation is a function. Okay, remember, for something to be a function, that means for every x value, there's only one corresponding y value. Here we've just flipped that around and we say for every y value, there's only one corresponding x value. That means your function is one-to-one. Why do we care about whether or not a function is one-to-one? Well, we'll see later on when we do another series that they're special because they have an inverse function. Okay, now we don't know what that is at the moment, so we'll talk about that later, but that's why these one-to-one functions are special. So let's try and figure out which one of these following examples are one-to-one functions. So here we've got our first function, f of x equals x. Okay, what you should recognize is this is simply just the equation for the graph of a straight line with a gradient of 1 that goes through the origin. Okay, so what that would look like is something like this. Here we go. Okay, now how do we work out whether or not this is one-to-one? Well, we look at the definition and we say for every y value, there is only one corresponding x value. So you pick a y value, you say, all right, let's pretend, well, let's say we've picked this y value here. Okay, is there only one corresponding x value? Yes, it's that x value here. Okay, pick another y value, let's say this y value here. Is there only one corresponding x value? Yes, that point there. Okay, in fact, no matter what y value you choose, you can always find only one corresponding x value for this particular function. Okay, so that means this function is one-to-one. Right, what about something else? Let's say we've got another function, g of x equals x squared. Okay, you should recognize that this is, this is the equation for a parabola. So let's draw our Cartesian plane. And let's draw our parabola on top of that. So we know it's going to look like this. All right, now we've got to ask ourselves the question, is there a y value that has multiple x values? Well, think about it. Can you see a y value that might have multiple x values? Well, in fact, any y value that's greater than 0 will have that condition be placed on it. So let's choose this y value here. Okay, that corresponds to this point there, which has an x value of whatever that is, call it x1, but it also has a corresponding point over here, which is another x value, call it x2. So for this particular y value, whatever that happens to be, there are 2 points that have that y value. Okay, therefore it is not one-to-one. Okay, for it to be one-to-one, it should only have 1 point for every corresponding y value. Okay, let's look at something similar to that one. Okay, we've got this function h of x equals x squared. It's got the same rule as g, but notice the difference here is in its definition. Its domain is from 0 to positive infinity. So if we were to sketch that one, what we would get is something that looks like this. it would be the same parabola that we drew in the middle here, except it starts at 0 and goes off to infinity like that. Okay? Now you should be able to see that no matter what y value we choose, you'll always only get one corresponding x value. So you choose a y value of this, there's your x value. Choose a y value of this, there's your x value. Okay, there's only ever one point for each y value that could be chosen. Therefore, this is a one-to-one function. Okay? Now, just as we have a test, vertical line test for testing whether or not something is a function in general, we have a test for whether a function is one-to-one, and it's called the horizontal line test. It's exactly the same as the vertical line test, except we're drawing a horizontal line instead. So, if a horizontal line can be drawn anywhere on the graph such that it intersects the graph at most once, the function is said to be one-to-one. Okay, let's look at the previous examples. First one here. You can draw a vertical line anywhere you like. Horizontal line. There, anywhere you want. That horizontal line is only ever going to intersect that graph at most one time. Whereas with something like this parabola in the middle, you could just draw a horizontal line there, and it's already crossed it, it's already intersected the parabola twice. So therefore it's not a one-to-one function. Okay, so that's how we apply our horizontal line test. Okay, alternatively, just like with that parabola, if you can draw a horizontal line so that it does intersect the graph more than once, then it's not one-to-one. In fact, we give it another kind of name. We call it a many-to-one function. Okay, so y equals x squared. If you are using the largest possible domain, that's not one-to-one, we call it many-to-one. Okay, because there are many x values for one particular y value. That's what that means. Okay, and just note that even if a graph passes the horizontal line test, that doesn't automatically make it a one-to-one function. It still has to pass the vertical line test to be called a function in the first place. Then after that, you can test whether it's a one-to-one function by doing the horizontal line test. Okay, so it has to pass the vertical line test first to be called a function. Then you can check whether it's one-to-one. Okay, so let's look at some examples. So there's our parabola, y equals x squared. It's not one-to-one. It does not pass the horizontal line test because I can draw a horizontal line and it intersects twice. Okay, y equals 2x plus 1. It is one-to-one because no matter where I draw a horizontal line, it's only going to intersect that graph once. Okay, here's a graph of y equals 5. It's just a horizontal line going through the y-axis at 5. And notice you can draw a horizontal line on top of that, and this blue horizontal line is intersecting this red graph at infinitely many points, okay, because they're the same line. So because it's intersecting more than once, then it's not one-to-one. Okay, here's a graph of y equals x to the power of 3. It's a cubic function. We haven't seen these yet. But again, just like this 2x plus 1, you can draw a horizontal line anywhere you like, and it's only ever going to intersect that graph at one point. Okay. And finally, here's the top half of a circle. It's not one-to-one because I can draw a horizontal line here, and it intersects twice, therefore it's not one-to-one. Okay? So that's how you can check whether a function is one-to-one. So here's a bit of a summary. Okay, this is sort of like the hierarchy of relations. Okay, so you can just have a relation in general. Then you can test whether the relation is a function by checking whether it passes the vertical line test, or whether it's not a function if it doesn't pass the vertical line test. Then if you've figured out that it is a function, you can check if it's one-to-one by doing the horizontal line test. If it passes, it's one-to-one. If it doesn't pass the horizontal line test, you can call it many-to-one. Okay, but mainly we're focusing on the one-to-one part of this. Okay, so there we go. That's a one-to-one function. Passes the horizontal line test. We'll stop the video there. I'll see you next time.